we start with some example. Okay, this will be the last one. Sorry, not really the last one, but it will be the last easy one to trace. Because after this one here, I'd like to do another example for equals method that's going to involve array. All right, but let's do this one first as a warm-up. All right, let's now take a look. So for the example here, part 1, we are considering point V1. If you recall, point V1 does not have the overridden version of the equals method, right? So we got an object version to be called. This one easy, but let's do it. So this will be the JUnit test assertion that we want to really get through. And by the way, the example code of this is also on the lecture site. Do download it, play with it, run debugger if necessary, just play with it. That's the shortest way, I would say, to really learn about it. Okay, let's now do this one here. So we got P1 and also we got P2, 2 objects here. So for P1 is 3 and 4. For P2 is also 3 and 4, but they're different objects. And if you do P1 equals P2, obviously it should be false. That's why when you say assert false, it's going to pass. I'll just say P here, so you know what I meant, pass. And if you say P2 equals P1, doesn't matter the order. In this way, it's also going to be false, so assert false is also going to pass. Again, it don't really say if an assertion is true or false, either pass or fail. Sometimes you might try to assert some expression that's expected to be false. Sometimes you might want to assert some expression that's expected to be true. So it depends, right? And since we are comparing references over here, you can also try assert the same, either P1 followed by P2 or P2 followed by P1. Doesn't matter, because in this case, they're different objects, so both assertion here will simply just fail. Not just false, it will fail. All right? And let's now try to do equals. You can see I intentionally try 2 things over here. I got P1.equals, where P1 is the context objects. I also got P2.equals over here, right? The context objects. Now, are they going to call the same version of the equals method, even though I got 2 different context objects? They are. The reason is P1 and P2, they are dynamically pointing to point V1 here and also point V1 here as well, right? So these 2 dynamic types determine which version that's going to be invoked. So what I would do is I'm just going to make some indication here. You can see this one tells you P1 dynamically is point V1. And this one tells you P2 dynamically is point V1 as well. So the same version of the equals method will be called. But don't assume it. Sometimes it might be different, right? Which we'll see in the later phase of the example. All right, so after analyzing this, now it should be very clear to us to see the result. So now the equals method is going to be the default version. So this will simply boils down into P1 equals P2. And this one here will also boil down into the default version, which will be P2 equals P1. Right, so both of them is going to return false. So that's why assert false will pass. All right. Yeah, and if you want to just compare the contents, so far at this point, we don't have any overridden version of the equals method. So if I really want to compare P1.x, P2.x, the only way I can do it is by writing this out. All right? That's just another example here. All right, that's phase number 1 for the example. Any question? Okay, should be quite good. Let's now move on to the second part. All right, let's now move to the context where we got our overridden version for point V2. So whenever the context object has the dynamic type, for example here point V2 and point V2, we are going to invoke this version only. This version here will be irrelevant. All right, let's now take a look. Let's say we got P3 over here. That one has 3 and 4. We also got P4 over here. That one there also got 3 and 4. All right. Now, P3 equals P4, for sure it's going to be false. And P4 equals P3 also is going to be false. Very easy to see. And accordingly, if you try to assert the same, P3, P4, or assert the same, P4, P3, both of them are going to fail. Different objects, right? So far, we haven't touched the equals just yet. Right. And let's now move on to the next two lines. Here, P3, here, P4. The context objects, right? Different. Again, you want to refer to the dynamic types for P3 and P4. So now in this case, for P3, the dynamic type is over here. For P4, the dynamic type is here. They happen to be the same. Again, they don't have to be the same, right? Which we'll see in later part. So that means in this case, we're going to invoke the default version of the equals over here. And for this one here, we're also going to invoke the default version over here. And for the tracing, I'm going to leave it to you because we have done that so many times. And for this one here, P3 and P4, you can see the contents are just the same, even though they are different objects, right? So it's going to return true. Okay? And P4, P3, also, even though they are different objects, but they are the same, content-wise. Also true. All right, and then if you try also assert equals. And notice one thing here. I'm just trying to show you the equivalent way of doing things. If you think about number 1 here and number 2 here, they're really doing the same thing. For number 1 here, I'm saying assert true, and then P3 dot equals P4. Versus in number 2, I say assert equals. And then P3, P4. They are really the same thing, really. Okay? The only difference is I'm using 2 different assertions. One is this one here, and one is this one here. You can say that doing this is as if you wrote something like this. Of course, assert true is more general assertion. You can put any expression you like. That's going to return true, right? But I'm just showing you that equal. All right, any question about this part here? Also very straightforward. The only difference is we are calling a different version of the equals. All right, if we move on, the next, the next logical step is to see what if the context object and the arguments have different dynamic types. How are we going to deal with it? All right, now it will be important. So now we're going to put the 2 classes into the context. We have point V1 without any overridden equals. We got point V2 that has the overridden equals. All right? So now we have to see very clearly about the dynamic type for the context objects because it can be either point V1 or point V2. And the equals method to be called accordingly would be different. Okay, okay, let's now go over them. Let's start by using, P1. So P1 over here is going to be 3, 4. 3, 4. As you can see, dynamic type for P1 is this. All right, point V1. On the other hand, we're going to have, let's say, P2. P2, we got 3 and 4. 3 and 4. However, it has a different dynamic type, even though X and Y are the same. All right? So this one here, point V2, you can see the dynamic type is different. Okay, I'll put here dynamic type, and here, that would be the dynamic type. Right? You can see very clearly where things come from. Now, I do have some highlights over here. Let me use a different color here, otherwise it might be confused with the orange. I want you to look at these 2. I'll make it a little bit larger just in a moment. I want to box them first. Okay, if you can please look at this one here and this one over here. All right, now let's say the first one here. Is it going to pass or fail? Or something else? Does not compile. That could be one option. Anybody else? Okay, so since I've got 3 options here. pass, fail, or does not compile. Anyone? Sama, why would you think that doesn't compile?
Because there are different classes.
There are different types over here. You cannot really compare orange with apple directly, right? Explicitly. That's good. So if you guys try this one here to write down P1 equals P2, explicitly, it's not going to compile. All right, so not going to compile. And it's not going to compile because you can see for P1 and P2, point V1 versus point V2. You cannot compare two variables of different types directly. You just cannot. All right, so that's not compiling. On the other hand, if you try these two, assert the same, and then I put P1, P2, and P2, P1, right? Now, for the first one here, it would be as if, implicitly, I'll put in quotes, P1 equals P2. You don't really write it explicitly, but that's something behind the scene Java runtime will do for you, so that's okay. So this one here compiles. Whenever you're trying to write an assertion, assert the same, this first expression and this second expression here can be anything, just any objects, including if they are different types. That's okay. So there's a critical difference here you want to see, right? If you want to compare two things of different types explicitly by yourself, no, it doesn't compile. But if you write assertion like assert the same, assert equals, whatever, it might boil down into comparing two different things. But that's okay. It's not your responsibility. Right? So there'll be no compilation error. All right, so let's now move on. What about this guy here? P1 dot equals P2, P2 dot equals P1. All right. Let's now be very critical here. Let's say P1 over here. P1 context objects star. And also P2, I use orange, so let me be consistent. So P2 over here, star, star, right? So let's now write down what we need to know. So for star, the dynamic type of the context objects is point V1, exactly here. That tells me the default version of the equals method from object class is going to be called, because there's no such methods overridden in the point V1 class. On the other hand, when I talk about star star over here, the dynamic type is different. Of the context object is now point V2. Because you can see P2 indeed has dynamic type point V2. That tells you it's going to invoke this version of the equals method instead, right? Be very clear about which version is going to be invoked. This will be star, and this will be star star. All right? And let's now try to see what's going to happen here. If we try, how about this? Just by looking, I'll try to make it as much as possible, okay? I want you guys to think about it for one moment. Let me tell you something to begin with. I say P1 dot equals P2, I can tell you that this is going to return false. I'll tell you first. That's why assert false is going to pass. P2 dot equals P1 is also going to return false. That's why assert false will also pass. Now, here is my question to you. Does this assertion pass for the same reason as this assertion passes? I'll write down the question, but I want you to think about. The question is going to be about this, right? So question, do these two assertions pass for the same reason? I can tell you that it shouldn't in some way, because I already told you P1 here is going to invoke this version, and P2 over here is going to invoke this version. All right, so now I'll pause for 1 minute. This is what I expect to hear from you. Tell me for exactly what reason number 1 is going to pass. And for what reason number 2 is also going to pass. Number 1 here and number 2 here. Okay? Pause for 1 minute. Think about it. This is critical. Okay, just one more moment. Okay, for number 1, when I say P1 dot equals P2, why does it evaluate to false so that assert false pass? Robert, go with you first.
Because when you're calling the non-overridden equals, it's the same thing as we just talked about.
Yeah.
Comparing different types.
Yeah, different objects basically, right? Okay, that one's easy, but let's be sure by writing it down. So for star over here, it's basically going to boil down into P1 equals P2. And of course, it's going to be false because they're different objects. Okay? That's why number 1 should evaluate to false. So making assert false pass. What about number 2 here? That also evaluate to false for this expression here. But why is that? Tell me why and exactly which line determines we should return false from that dot equals method.
We're tracing because the context
Yeah. Go to this one here, right? Mm-hmm. 1, 2, 3. Mm-hmm. Yeah, that's pretty precise. Thank you. Yeah, let me just repeat your point if I may. So here for star over here, we know that we're going to execute the equals method from point V2. And then as we're executing it, just don't forget we got P2 being the context objects. When we get to this point over here, P2 will be here. And also OBJ will be here. Right? P2 dot, yeah, exactly. P2 dot equals P1, just be sure. So now, what about P2 dot get class? P2 dot get class is going to give you point V2. P1 dot get class is going to give you point V1. They are not equal to each other. They are different dynamic types. So that's why this not equal to is going to evaluate to true. So you will execute the body of the if branch, which is going to return false. So that's the reason. So you can see both P1 dot equals P2 and P2 dot equals P1 both evaluate to false, but for different reasons. Different part of the code is being executed. That's the main message you want to get. All right? How do we know? Because the dynamic type for the context object is different. All right? All right, any question here about this? Yes? Yeah. Mm-hmm.
The parameter obj, it's object.
Mm-hmm.
Why doesn't obj.getClass return object?
Because, okay, that's a good question here, fair one. The question was, here, okay, first of all, you can see P1 currently is pointing to point V1. That one we agree, okay? And now if you look at the declaration here, objects over here is declared to be objects. That means its static type is objects, all right? But when we say P1 that get class, we're asking for dynamic type, not static type. So what you said would be objects over here is not right because static type doesn't determine what the get class will return, only the dynamic types. In this case, P1 that get class is going to search through. P1 is actually going to go to this particular object here, and then it's pointing to P1, point V1 objects. That's why. Okay?
So even if like
Doesn't matter. So get class, easy. Get class, simply return the dynamic type. Doesn't matter what the static type is. Yeah, good. That's a good question. Yes. In which case is it going to be true? Well, we're going to see something. In this case, I can tell you it should not be true because P1 and P2, yes, we can see that 3, 4, and 3, 4. It's more like an apple and banana. They do share some attributes in common, but you cannot say apple is equal to banana, right? So it doesn't matter how this method should be defined or how this method is defined. Since you're comparing two objects simply dynamically of different types, they should never be equal to each other. So that should be false. Yeah. Think about equality goes like this. You should only compare two things if they are of the same types. If they are simply of different types, it doesn't matter if they share some attributes in common. They should just be unequal by definition. Alrighty. And the last phase for the example will be very similar. Okay. Oh, is this the last one? Okay, that's the last one, it seems like. Okay, good. I think that's it. Okay, good. Right, so this will be the last phase for the exercise. So guys, one more thing to say before we move on to something else. You really want to convince yourself these two are really calling different versions of the equals method, even though they both evaluate to false, right? That'll be the final message. Let's now go back to this PersonCollector class, which I want to finish. About tracing it, maybe it's not into 100% detail, but there will be some subtleties you want to pay attention to. It's really important to really learn from there. All right, very recap about how the PersonCollector class will look like. Okay? Before that, we already talked about person class, right? And we talk about for expression like this, how do you know which version of the equals method that's going to be called? We also talk about analyzing such dotted notation, right? Also make sure you can do it. In the actual lab, in the test, you might be given something even longer, even more dots. But the principle of analyzing which version of equals should be called will be just the same. You just got to start from the left all the way to the right. Okay. Alrighty. All right, let's now go back to this PersonCollector class. Okay. So we got a PersonCollector here. We got persons array. We got some counter. So these are the only two attributes we have for the PersonCollector, meaning that these are the only two things you may want to compare two PersonCollectors. So that's what the equals method is going to be defined somehow. But we'll see. And we got constructor, we got mutator, we got accessor, etc. They are standard, right? And let's now take a look at how we overwrite the equals method over here, right? So we got these two lines. They are just standard, right? I don't need to repeat. And also we got some casting over here. We also spoke about quite exhaustively, well, quite thoroughly, before, even before last Thursday. So how do you understand the cast? You can refer to the example earlier. What we have over here is we have a Boolean variable called equal. And then eventually we're going to return equal, which might be true or false. Okay? Again, I would discourage you to really use any continue or break statements in Java. It's not a very good practice. For small scale example, they might be okay. But once you talk about software projects in large scale, using continue or break is going to cause some maintenance issue for your project. It's not worth your risk. Okay? All right, so what we do is we first of all consider if the number of persons in two PersonCollector are the same. If they are not the same, that means we simply return the equal default value, which will be false. Right? If the two collectors store different numbers of persons, of course they are not equal. Right? Maybe one stores 5 persons, the other one stores 4 persons. There's no way they're equal. If the number of persons they store in the collection are equal, in that way we're going to continue using a loop to compare, basically one by one. Okay? So let's see here. So for example, let's say, let me show you some diagram very quickly. At the runtime, you got two PersonCollector objects. Let's say you do have some person at each index. If their NOP are the same, let's say, what you would do is you're going to compare the person that's stored in index 0, and also person at index 1 and index 1. If the persons you're looking at the current index are the same, you go ahead and continue comparing the next person in the array. As soon as you hit the very first index where the two persons stored in the two collectors are different. In that way, you know it's now time to return false for the equal. All right, so that's kind of the general idea. And you will do something very similar, maybe for your lab number 3 as well. Okay. And of course, we got to do some tracing just to make sure you're feeling more comfortable about running this code. Right? So if you look at the code structure, nothing else to say. You just want to make sure you understand why the equal can be part of the conjunction here. Right? So remember in the for loop, the middle part tells you as long as this part here evaluates to true, you're going to stay for more iterations. As soon as this equal here becomes false, how can it become false? Equal is going to be reassigned to, we try to compare the person at index I and another person at index I from the two collectors. As soon as we find that they are not equal, then we're going to set equal to be false. In that way, once equal becomes false, you're going to make this conjunction here false. So we exit from the loop. So once you exit from the loop, you're going to return the false for the equal. Right, so these are the different scenarios we might run into when we do tracing. But it's always good to kind of sketch a little bit in your mind to see how things might occur. So we'll see. Yes?
But if, for example, given two objects, let's say their NLP is equal, and the elements in both objects are equal. However, let's say for object 2, the index for the elements are different from the index in object 1.
Okay. It really depends on how you define the equals. Of course, there might be multiple ways you can define that. But for our purpose over here, we do a very simple way. We say the following. So number one, we first check to see whether the number of persons are the same. If they are not the same, they are not equal. If they are the same, we're going to look at the contents of the two arrays over here. The way we look at that is by looking at pairwise persons stored at the same index from the two collectors. So index 0, we don't really compare, for example, index 0, index 1. We don't do that. That'll be too complicated for this example here. Although, in some occasion, you may want to say, somehow, I don't want to care about the order. If I somehow got person 1 in one collector, as long as person 1 is equal to some objects in the other collector, in that case, you might need a nested loop. But that's too complicated for now. That's something for you to work out maybe in the lab later. All right? Right, so guys, the main message over here is this. How I define the equals for the person collector in some way is really for illustration purpose in the class. So I make it a little bit naive, but easy to understand so you get an idea. Realistically, you may not necessarily want to compare persons in the same index. You may want to be more flexible, but it's really up to your definition. Okay. All right. Okay, we got to do some tracing. That's important. All right, so that's about the equals method. Any other question just about the code itself? Not very long, but I think it's important for you to especially see how you can use a Boolean flag, we call variable here. All right, and just to remind you, we also got another class called person, which we also spoke about last Thursday. The person class also got their own version of the equals, which will compare the weights, height, first name, and last name. Right? So we might need to use this as well. Okay, let's now try to trace. I got 1, 2, 3, 4. 4 different scenarios for us to go over. But they are not too bad. Let's start with some simple one. So let's say we want to create 4 persons, P1, P2, P3, P4. All right? And for P1 here, it's going to be first name A, last name A. Let me just be sure about, I believe his first name A, last name. Okay, let's say that's the case. Okay, first name, last name, and then the weight, 180. The height will be 1.8, right? And person number 2, similarly, A, 180, 1.8. Different objects, but the same contents. P3 is B, 200. 2.1, right? I'm just following exactly what's being passed to the constructor. And P4 here, no new objects. What we do is we simply say P4 is assigned to P3. Okay? And some simple comparison. P1 equals P2 should be false. They are different objects. And if I try P1 dot equals P2, right? So now the only thing we want to know is which version of equals is going to call. In this case, P1 dynamically is pointing to person. So we know the person equal is going to be called. In that way, we are comparing P1 and P2, and we are going to pass these two lines for sure. That's something you can convince yourself, right? They're the same dynamic type. And also OBJ, in this case P2, is not equal to null. So we are fine. And when we get to this point over here, we're going to compare their first name, their last name, their weights, and also their heights, right? They're all equal. In this case, the return is going to give you true. Okay? And then when we try to do, let's say P3 equals P4. P3 and P4, they are the same objects. Of course, equal is going to give you true. And then we try to do P3 dot equals P4, right? Now, P3 dynamically is pointing to person. So that's why the equals here should be, again, this version over here, right? From the person class. And then we're going to compare basically the same objects. And you can see this right away. If this equals OBJ, so P3 is the this. And P4 is the OBJ, basically, right? So they are the same objects. In that way, we're just going to return true right away. Right? Also easy to trace. And of course, important to notice, if you look at this line here and also this line over here, okay? It turns out the equals over here is being called for the same version, just the equals over here in both cases. This one here is going to give you true, but it's because this part here returned true. They are the same objects, but they are different objects, but the same contents. On the other hand, the second one over here, when we compare P3 and P4, again, we're calling the same version of equals, but a different line over here that returns the true, not this part anymore. Right? That's something for you to notice. Right? Any question about the scenario number 1, which is not too bad. We haven't even touched the PersonCollector yet, but we will. Right, the example is going to build up. So if you download the source code I made available to you, you will see all the JUnit test cases there. So you can play with them, again, using debugger on Eclipse, and feel free to verify free to modify them and make your own example. Okay, number 2. Let's now put PersonCollector into play. We got PC1 and we got PC2. You can see PC1 here is going to just standard constructor. So that's why I don't really trace from scratch. So the PersonCollector object has NOP and persons. And NOP initially is 0, and then let's say the maximum capacity is 100, let's say. So you can see the array here has been created, and every slot in the array is null. And notice that we got 2 separate arrays. One belongs to PC1, the other one belongs to PC2, because the attribute here, by the way, is non-static. All right, I'm also trying to review a little bit what we spoke about earlier. And first of all, let's try PC1 equals PC2. That one should be false, because they're different objects. All right? That one should be very easy to see, so this one here should be false. What about PC1 dot equals PC2? This one's interesting. All right, very interesting. PC1, first of all, dynamically is pointing to PersonCollector. So I'm going to just make some color annotation for you. If you look at PC1, the context objects, dynamically PC1 is pointing to PersonCollector. So that's why you're going to call this version of the equals from PersonCollector. Okay? The same decision making that we spoke about. And question for you. At this point, you can see there's no person stored in either of the array. NOP here and NOP here is actually both 0. I want you guys to really take a look. I'll make this one a little bit bigger. Right? Just remember this diagram here, right? So 0, 0, and also the same length of the array where every slot is null. But if I try to call PC1 dot equals PC2, exactly which line are we going to execute, right? Why don't you guys take just 1 minute to think about? This one is a little bit trickier, but it turns out it's actually quite simple, right? That's my question. Number one, should it return true or false? Number two, exactly which lines are going to be executed? PC1 equals PC2. Okay, just take 1 minute. All right, 30 seconds. All right, 10 more seconds, and then we can see if you got any thoughts to share. If no, I will share some thoughts with you. Alrighty, any idea? Number one, should it return true or false? These two person collector. At the moment, they have no person collectors in either. Should it return true or false? Anybody? True, I agree. And follow up, right, which is more important. If it's going to return true, which line exactly are we getting the true from? Are we getting return true from here? Cannot be, because TC1, PC2, they are not the same object, so it cannot be this line, okay? And also, PC2, the OBJ here is not null. And also, they are dynamically the same object, person collector. So this one here and this one here, they're not going to be executed. So that means this part here is going to be bypassed. This one here also is going to be bypassed, right? I'm tracing this line specifically. And we're going to do some casting, right? And then we're going to execute this part of the code. And then we're going to initialize the equal to be false. That's good. And NOP, 0, 0. True. That means we're going to go ahead to execute this part further. All right? And as soon as we get to this if branch, we're going to reassign equal to be true. So at the moment, equal has been reassigned to true because we have a chance to get the two things equal. Now, here we are more focused. Guys, question for you. Look at the header of the loop. What's going to happen when we run the header of the loop for the very first time? Are we even going to go into the loop? No. Jennifer, why not?
Because the number of persons is 0.
0, and then somehow 0 less than 0 would be? So the line you want to really look at is this line over here. All right? This line here, we know that over here, this is the context object. In this case, this is PC1. Right? So we got PC1.NOP, which is referring to this value over here. Right? In the beginning, it is 0. And the loop counter, initialized to be 0. So we got both 0. So 0 less than 0 is going to give you false. What does that mean? There is no person from PC1 to compare against, nothing. All right? And we know that both arrays are, both person collectors store the number, the same number of persons. So that means at the moment, they simply store none in both arrays. In that way, we just don't need to compare. So this way, we don't even need to run any iteration, just return true. All right? So that's a critical point for you to see. All right, I'm going to write it down here, just quickly. So here, because I less than this NOP evaluate to false right away, no iteration, run. And then we're simply just going to return the value for the equal, which corresponds to the true that we set it to be. All right, so this initial case here is pretty simple, but it's a little bit subtle. You want to know exactly how it's returning true. You see, because we simply have no persons to compare with, all right? Which makes sense. Conceptually, if you got two person collector, both of them are empty. In that way, they should be considered as equal. All right. All right, any question about this scenario here? So in the latest scenario, we're going to see non-empty cases to see what if, let's say, the two person collectors store maybe the same number of persons, but somehow the person may or may not be equal, or they simply store unequal number of persons. Right? So these are the cases we want to see as well. All right, any question about scenario number 2? Really make sure you understand this one here. That's really critical. All right, number 3. What we do is, well, we still got a person and person collector here, just for reference. And now we're going to add in P1, P2, P3, and P4 that we had from scenario number 1. Right? Okay, let's take a look. Let's now just walk through what's going to happen before we trace it. We're going to add one person, P1, into PC1. And then we're going to compare the two collectors right away. And then we're going to add another person to PC2, and then we're going to compare if they are equal. And then we're going to add another two persons into the collector and then compare them again. Right? That's kind of the pattern we're trying. So you really want to be sure up to which point do you have which diagram state, right? It's important to really update your diagram as you're going. Okay, number 1. Let's see over here. If I say PC1 dot add person P1, so PC1 is here, and if you want to add a person to it, we know pretty well how to do this. So now PC1, rather than pointing to now at index 0, so now it is going to point to P1. And then update NOP to be 1. All right, very simple line. And that corresponds to what we have learned for so many times about the programming pattern. And let's now try to do PC1 dot equals PC2 right away. All right? And because PC1 dynamically is a person collector, so we call this version of the equals in person collector, which is here. Okay, I'm going to save the time a bit to tell you. What's going to happen is, dynamically, these two are of the same types. Person collector and also person collector. Somehow I missed it in the title, but it's person collector. However, you can see the NOP here, they are not the same. So this is where we're going to return false for this equals call. Right? Because NOP and NOP here, they're not the same. So this is exactly where we're going to get the problem. Okay, so here, this is the line where, okay, so let me just write it down here. At this point, PC1 dot NOP at the moment is 1. Is 1, and also PC2 dot NOP is actually 0. So they are not the same. So we are simply just going to return the equals initial value, which is false. Right? So the very first comparison is going to return false. Any question about this? We're comparing two collectors with different length, with different numbers in the collection. And the next one here, we're going to just add another person, PC2. Okay? P2, add P2 into PC2, basically. Right? So that one there, PC2 here, and then we're going to add, so this part here, rather than pointing to null, so now we're going to say P2 is going to be added. So that's what we do. All right? And then we're going to update NOP to be 1. So now you can see if we run the equals again, we wouldn't actually just reject them right away because they are unequal number of persons stored. Right now they are equal. You can see now NOP for this one is 1. NOP for this one is 1. So we are not going to return false just because this one fell. Not anymore. All right? That's the subtlety you want to notice. But what's going to happen? If we go in there, over here, what's going to happen is we're going to run the loop because now we have non-empty case. What's going to happen is when we execute this loop over here, let me just write it the first time. So I will be 0, so that means this dot persons at index 0 for the very first iteration dot equals, and then other dot persons at index 0, right? I is currently 0 for the very first iteration. And that we know that since we are calling this, so this will be PC2. Other will be P2. So this is PC1, sorry, PC2, beg your pardon. That's PC2, and other here is PC1. And we are basically comparing the person stored at index 0, which is here, and also the person stored at index 0, which is over here. And now the way to compare these two person objects, you can see they are different objects. If you simply compare their references, we're going to fail. But we are calling the equals method from the person class. This is important. In the PersonCollector class equals, we are calling the in the PersonCollector. Right there. So the equals method here comes from the person. So what I really meant to say was, when we are trying to override the equals method in PersonCollector, we are making use of the equals method from the person class. This is very normal. Within the equals method of one class, you may call the equals method from another class. That's what we're seeing here. All right? And if you compare this person here and this person here, you can see content-wise A, 181.8, 181.8, the same. So that's why this line over here is going to give you true. So if you try to execute this line over here, it's going to give you true, right? It's going to be true because PC1, let me write this down. It's true because I'll put star here, and you can refer to this part over here, right? It's really that first iteration we're calling. We go to the first index and the first index in the two person collector, and we found that the person here and the person here, they are equal as far as the definition of equals goes in the person class. All right. Okay, let's do two more persons. Okay. And what we do is we want to add P3 and P4. You can see P3 and P4, they're really referring to the same objects over here. Right? So what we do is we're going to say add P3 into PC1, add P4 into PC2. How the diagram should be updated, that's important to see. Okay, so let's see this. So how about these two lines? So P3 and P4. So P3 is pointing to here, so we're going to let PC1 at index 1 over here. So rather than pointing to null, it's now going to point to this object over here. All right? And also for PC2, index 1, rather than pointing to null, it's now going to point to this object over here. All right? So far, it seems like we are growing the PC1 and PC2 one by one. And the person we added to the corresponding index happen to be equal, which is okay. And finally, if you try to execute this line here, PC1 dot equals PC2, right? Similar idea. So what's going to happen is, because you can see we're going to compare index 0, referring to this person here, they are equal. And then when we get to index 1 over here, that one is referring to this person here, and that one there, oh, I just went to the wrong person. That's my bad. Let me just fix that. So what I did wrong was this line here. It should be P4. Okay, P4 here. So index 1 should be pointing to P4, which is the same objects. Okay, it's good I've spotted that. It's now fixed. Okay, so when we actually execute PC1 equals PC2, comparing index 0, which will be these two persons, they are equal. We know that. In the second iteration of this comparison here, we're going to look at index 1, index 1. And they're both pointing to just the same objects. Now, with the same object, we know that person equal is also going to return true. Because over here, this is where we're going to see the return true. Okay? So if you think about this is star, star, star. And this is where star, star, star is going to return. So that will be true. I'm only trying to highlight exactly what you're supposed to pick up from the example. What you should really do is try to maybe trace the code by yourself first, so you will really appreciate so many details over there. And then you can revisit part of the lecture and see the highlights I'm talking about. Okay? Any question? We got one more scenario, but before I move on, any question here? Don't lose the big picture. What we're doing here, I know there are many details here. It could be slightly confusing, but you just need to dive into details. The big picture goes like this. When you actually got two objects over here to compare for equal, individually, they have some array and array. How do you compare them? Unavoidably, you have to use a loop. And the naive way to compare would be, I simply go over this array and go over this array, which is what this loop is doing. I go over this array one by one. I go over this array one by one. And look at index 0. Is it equal to index 0 over here? If it is, I move on. Is this index 1 and index 1 equal to each other? Yes, it is. So I move on. Let's say, for example, if I get to index 2 and index 2, somehow they store persons which are not equal. In that way, I know that I should really set this equal Boolean variable here to be false, which is going to cause the loop to exit. In that way, I'm going to return false. So that's a big picture. All right? Okay, questions before the last scenario. All right, that's now the last one. The last one, basically, I'm going to add a fourth person. But that fourth person somehow is not the same. All right? That's the trick. So this diagram here already shows you where we have got so far. We got basically two persons in PersonCollector 1. We also got two persons in PersonCollector 2. So far, the persons P1, P2 are equal. And also this one here, and also this one here, they're also equal so far. That's what we did in scenario number 3. Then let's do the final one. What we do is we say PC1, the add person, we got a new person here. And also PC2, add another new person. Notice that these two persons are not the same. The heights, for example, is not the same. You can see that right away, right? Okay. So what we do is we got two person object over here, which I'm going to put here. Let's say the very first one. This one is A175, 1.75. And the second person will be A165, 1.55. Right? These are the two persons. And then when I do add person, the first one. So PC1, currently NOP is 2. So rather than pointing to null, it's now going to point to here. This new person here. All right? So that's a new one. And then when I say PC2, the add person, I'm going to add this person over here. So index 2, corresponding to this, rather than pointing to null, is now going to point to here. So it really boils down into comparing this person over here and also this person over here. They are at the same index that we just added. Okay? And the final code for you to really convince yourself is, what if we say PC1 dot equals PC2? Right? Let me tell you the highlights. What's going to happen is we know that PC1, the context object, is pointing to dynamically PersonCollector. So again, we're going to talk about this equals method here. And then the critical thing is when we get to this for loop over here. At this point, this .NOP, this is PC1. PC1.NOP, oh, by the way, after adding this third person, it will be 3. Right? I just forgot the updates. This will be 3. So this .MOP will be 3. That means I is going to be 0, 1, and 2. So I is going to be 0, 1, and 2. When I is equal to 0, we're going to compare index 0 pointing to this object here, and index 0 pointing to this object over here, comparing these two persons using the equals in person, right? That's iteration number 1. Iteration number 2, index 1 here, and also index 1 here, just the same object. That's what we did earlier. Now, iteration number 3, this is the critical one. Index 2 pointing to this person object here. Index 2 pointing to this person object here. If you look at these two, are they equal? Not really, because you can see 175, 165, they're not the same. Okay? So the highlight here would be PC1 dot persons at index 2. And then when we say dot equals PC2 dot, I'll try to write it a bit more legibly. And then I say PC2 dot persons at index 2, right? You can see I is now being used as 2. 2 and 2 here. And this is going to return false because we got, for example, 175 and 165. So this one here is going to give us false. So that means ultimately equal here is going to be assigned to false. So ultimately we return false. So this equals here will be false. Right? Very, very important for you to trace. I try to do it in a fast-forward motion, so you don't really get too much or too lost into detail. But I'm just telling you that should be the overall way to really trace the code, right? Which is important. If I give you maybe different classes, different equals method definition, you have to know how to trace, right? All right, any question?